Hi, I'm Paulo Possa from Euresys. In this video, I will show you how to create, modify and build a custom logic project using Vivado tools. With custom logic, you can embed your own image processing algorithms into a Coaxlink-Framegrabber, offloading these processing tasks from the PC host. So, let's start. First, we have to extract the files from the custom logic package provided by Euresys. The custom logic package is a zip file containing everything you need to create a new custom logic project. Inside this file, there are two folders. These folders are related to the Coaxlink-Framegrabbers that support custom logic. In this video, I will use the Coaxlink Quad 6B12, so I will extract this folder on my desktop. Inside the package, you can find a custom logic documentation, a collection of encrypted files and netlists that provide all Coaxlink-Framegrabber functionalities, a series of scripts to help creating a custom logic project and configuring the reference design modules. The main folder here is the reference design folder, where you can find the source files of the custom logic reference design. These source files can be used as templates for your own image processing modules. There is also a HLS reference design. HLS stands for High-Level Synthesis, which is a methodology provided by Xilinx to create FPGA IPs using C or C++ language. The release folder contains a pre-built bitstream file with the custom logic reference design and a README file that explains how to create the custom logic project. To create a custom logic project, we have to run the script create Vivado project. To do that, I will start Vivado. I'm using Vivado 2018.3. So in the TCO console, I will run the script that is located on my desktop. Source C user level desktop Coaxlink Quad 6B12 scripts create Vivado project. So this script will automatically create a new project called Custom Logic and will place all the resulting files inside of a new folder called Vivado project. It will take a few minutes. When it's done, we'll have a project called Custom Logic inside of a new folder called Vivado project. On the top level, we can identify the Coaxlink core, which contains all the Coaxlink modules, and the Custom Logic wrapper. The Custom Logic wrapper is where you can introduce your own image processing modules. I will open it in a different editor for a better visualization. The Custom Logic wrapper is located in the reference design folder and is called Customlogic.vhd. The wrapper gives access to all custom logic interfaces the custom logic interfaces are the data stream input and output, the memento interface, the control interface, and the memory interface. The memory interface gives access to the onboard memory. The modules included in the Custom Logic reference design explore all available interfaces, and they can be used as a starting point for your own designs. More information about the modules in the Custom Logic reference design can be found in the Custom Logic user guide. From this point, we can implement the Custom Logic project that we've just created, and then generate a new FPGA bitstream. To do that, we will simply run Vivado implementation. So this will take several minutes. When it's done, we can generate the FPGA bitstream. To do that, we can run another Vivado script that contains some useful functions for custom logic. So the script is located in my desktop. User, Labo, desktop, custom logic, scripts, custom logic functions. So now we have access to these functions, and we will use this one, custom logic bitgen. This again will take a few minutes. The custom logic bitgen script generates a copy of the new bitstream into the release folder. Now that it finished the bitstream generation, we can upload this bitstream into the Framegrabber's FPGA. To do that, we will use the Euresys Coaxlink-Framegrabber manager. So now we need to locate the new bitstream and drag and drop it here in this box. The new bitstream is on my desktop, the folder release. So I drag and drop, and then I can update the Framegrabber's FPGA with the new bitstream. Proceed. Okay. When it's done, we need to power off our PC and restart it to activate the new bitstream. So I restarted my PC, and now I have the new Custom Logic bitstream running on my Coaxlink-Framegrabber. I will use GenCam browser to test this new bitstream. On GenCam browser I can start an acquisition. By default, all modules in the Custom Logic reference design are deactivated. So to activate these modules, I have to use the Custom Logic control interface. For example, to activate the threshold, I will write in the address 6 at the threshold level, for example 100. In the same address I will write 200 in hexadecimal to activate the threshold. Now we can see the resulting image with the threshold activated. For the complete Custom Logic register map, please refer to the Custom Logic user guide. To show how easy it is to modify the reference design, I will use the threshold as an example. An interesting thing about the threshold module is that it was created using Vivado HLS. So the threshold reference design sources are located in the reference design folder. And the C++ file that was used to generate the threshold module is this one. I will modify the code to, instead of outputting 250 when the pixel value is above the threshold level, I will output the input pixel. I save the file. Now I can run a script that is provided with the HLS reference design. A script that will regenerate the threshold module. So to run this script I will use HLS, the command prompt of HLS, and I will run vivado -f c users lab desktop Coaxlink reference design HLS scripts, and that's it. Now it will regenerate the threshold module. It will take a few minutes. So now the threshold module was regenerated with the modification that we did. We can simply rerun the Customlogic project and repeat the procedure of building the project, generating the bitstream, and then uploading this new bitstream to the Framegrabber. As this will take a few minutes, I will jump to the result. So now we have the Framegrabber with the new bitstream, and as you can see, the threshold function is performing the modified algorithm, where the output is not only 0 or 255, but any shade of gray above the threshold level. So that's it. For more information on Customlogic, please refer the Customlogic user guide and also our website www.euresys.com. Thanks for watching.